It's a beautiful Pacific Northwest morning. A nice rain is falling, but not enough to warrant a raincoat. So I got a couple of Jeep 4.0 engine heads that I'm looking at. And these heads are made of cast iron. Okay, these are stock 7120 4.0 heads. They're made out of cast iron. And cast iron is a process where you take molten iron and you pour it into a mold. In that mold is going to be compressed sand. And that molten iron flows into the mold around the sand. And then it's cooled. That's essentially how this shape is formed. Okay, once that molten metal is poured, it's allowed to cool down. Then you take this cast shape out of the mold. You clean all the sand out of all the little passages. Then you machine it. Thread machined holes. And then you have a complete head. Okay, well, I got this torn down to parade rest. It'll be a good time to look at the manufacturing process of this. So first off, right here is the split line. See that? That's where two molds were formed together. Okay, the best place to see what I'm talking about is in that void cavity where your water jacket is. It's clear in there, see that? Where the two sides of the mold came together, and then the cast iron was poured. See in there also? So that cavity right there at one time was filled with sand. Okay, now we're going to look at it from the thermostat side. Right here again, there's our two molds coming together. And you can look in there and also see the split line running down there. Okay, once that molten iron is poured and it's allowed to cool down, you got to get the sand out of there, right? So that's what this opening is for. You get the sand out of there and then you install a plug there. That's called a core plug. Okay, it's going to be easy to get the sand out over here, right? These are big openings. That's your intake and exhaust ports. Okay, over here, thermostat opening. Any sand down here, that's going to be pretty easy to get out also, isn't it? That's a big opening. Look at this part of this casting. They never fully machine that opening right there. Okay, across the top here, 1, 2, 3, 4, 5, 6. That's 6 more core plugs. Those are threaded in. Those are also to get the sand out of the inside there after the casting's done. Okay, this side, there's no openings to get the sand out of here, is there? That's the galley that returns oil to the crankcase. Okay, how are we going to get the sand out from this side? Obviously, we'll be able to get it here. The openings where the valves are. But to get the sand out of the water passages, which are the most critical part of this, because you want to cool it down, energy from combustion in each of these chambers here is creating heat. It's basically a little explosion. So you want more of the cooling properties of your liquid, be it water or glycol, to be in the vicinity of the combustion chamber heat. So let's look at which passages are in this head to get the sand removed. We'll start here at the top. These obviously are bolt holes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These openings are to get casting sand out, but they do provide a little bit of cooling surface here. Okay. On the bottom here, sand can be removed from these openings, but it looks like they are used for water passage. Okay, then around the cylinders, we have more openings for sand extraction, but once again, those are supplying cooling properties to the water by having this surface area. The water can get in there, and that's more surface area to extract heat from the liquid, be it water or coolant. Okay, so water coming back from the radiator, being forced through the block by the water pump, is now entering the head. So let's refer to that water as conditioned water, cooled water, colder water. Okay, so each cylinder does get some cooled fluid through these holes in the gasket. But as the coolant flows through the block, the majority of it is going to come through these two passages here at the end. So a little bit of coolant supplied to each cylinder, but the majority is ported up through the block through these two openings and then flows back through to the thermostat. So kind of makes sense now why the temp bulb threaded boss is here at the end. That's where your water's coming up, and you're monitoring the temperature of that right here. On the 0630 and 0331, you'll just see a machine boss here. They no longer drill this and tap it. So the 0631 head comes out in 1996. And more modern technology is used to monitor temperature. So this is just blocked. Okay, we talked about the drilled hole on the 2686 and 7120 for our temp bulb. Here we have a bypass hole right here. That's the bolt hole for one of the crown bolts. So if the thermostat is closed, water that's getting pumped through the head by the water pump comes through this hole, enters the block, and goes straight back to the water pump for recirculation. Okay, this opening here, that opening is sending water to the heater core at all times. And that opening allowing coolant flow to the heater core will circulate water back to the water pump if your heater switch is in any position other than off. Okay, and then we have drilled and tapped holes for our intake and exhaust manifold. Drilled and tapped holes for our rocker / valve cover. This boss right here on the 7120 is for our air conditioning motor mount. Okay, these posts with the drilled and tapped hole, that's where our rockers are installed. Okay, on Jeep heads, the valve guides are part of the casting, and they're called in-cast valve guides. Now on this head, these are replacement valve guides. Okay, also part of the casting is our valve seats. Those are referred to as integral valve seats, but same concept, they're part of the casting. Okay, whoever changed these valve guides allowed a lot of material to be lost in here in the casting. That's not cause for ejection, but that could have been cleaned up a little better than that, because cracks could emanate from that. Okay, you probably have thought about porting your heads or polishing them, and that's the process of deviating the openings in the stock heads. That's essentially what happened over the years with the casting changes. People at Chrysler decided to let's change our mold to get more performance out of our engine. So that's essentially what happened over the years. So 2686 was your first casting. 7120, that actually started in 91, went to 95. Other modifications and improvements happened on the 0630. One of them was to block this port here and use more modern fuel control and temp control. And then the last one was the 0331, and that one, the engineers did not design that good, and then in-service cracks were found, and the cracks were between the cylinder combustion chambers. So that would be somewhere in this area. I've never actually seen those, but on this one we can see some cracks in the cast iron here. There's one here. There's one that extends all the way out to here, and then the integral valve seats burned on this one also. So the fix for the 0331 cracking problem was to add more material to the head deck. So imagine you make a mold, and then that sand that's compressed, you just change the shape of that a little bit, and when you pour the cast iron, you have more material up here on the deck. So that was the improvement to the 0331, and then the foundry put TUPY here. Okay, so there's no special manufacturer tuppy, still a Chrysler head. The foundry just put TUPY in there. So foundry markings, here's where you'll find your casting series. Here's the year. Here's other foundry information. Okay, is it a good idea to block these holes that essentially are there to just remove the sand? Well, that just depends on your maintenance philosophy and what your concern is when your engine's in operation. These certainly are not to allow fluid flow. They were to remove sand, but they do give you some cooling properties, this surface. When this cast iron is poured, for it to operate at the optimum performance level, they time the cooling of this. So at a microscopic, microstructural level, this is allowed to expand and contract and prevent cracking, stress cracks, fatigue. Welding these shut probably is not a good idea. Okay, this is a Clearwater aftermarket 4.0 head. And as you can see, the process was the same at Clearwater. They cast molten iron into a sand and mold fixture. Once it cools down, they got to get that sand out of there. And there's our openings. Now, Clearwater prides itself in a high-performance head. If they thought it was a good idea to weld these shut, you would think they would have done that. Edelbrock makes a cylinder head for the 4.0 out of cast aluminum. 50169 Performer, and that'll bolt on to any of the 4.0 engines as a replacement head. 2686, 7120, 0630, or 0331. Those are about approximately $2,000 a piece. I just happen to have a couple of pictures of those beautiful heads in my wallet. And I think we will observe that Edelbrock didn't close any of these casting sand removal holes on their Performer 50169 aftermarket head. Okay, here's our Clearwater aftermarket head. And here's a stock Chrysler Jeep 4.0 head. Clearwater is essentially the exact same design as the Chrysler stock. If we focus on the openings that allow the manufacturing process to remove sand, our Clearwater head essentially identical to the stock, and they did not close any of those openings after they removed the sand. And I just posted the pictures of the Edelbrock aluminum performance head, those also had the openings where sand is removed from the casting. They're not blocked. Okay, that being said, here's our head gasket. Here's our combustion chambers. The most common failure of this gasket is combustion gases breaching the head gasket and going into the water jacket. So I understand why people feel the necessity to block these, especially these in here close to the combustion chamber. So what commonly happens is there's an overheat on your engine. The levelness of the head, or perhaps the block, deviates from flat. Combustion gases now are allowed to escape past the sealing properties of this head gasket, and it enters the water jacket. You have high temperature indicated on your temperature gauge, and you probably change some parts out before you finally get to the realization that the head gasket's blown. So I understand. It's happened to me. Perhaps a JB weld in there. Some people do that. But welding that, you're changing the molecular structure of that. And you saw the crack that occurred. That was a 0630 picture. But on the 0331s, before they reinforced the deck with more material to prevent those cracks, those are fatigue and stress cracks we're talking about. And then in aircraft accident investigations, where there's loss of life, people retrieve those components and they can tell you exactly, usually, why a component failed, down to the microscopic levels of the metal. All right, the 4.0 is going to be around for a long time. It's been out of production now since 2006. We're still talking about them, modifying them, fixing them, and getting aftermarket parts for them. Okay, these stock heads are very reliable. This head had 3 cracks in it, and this thing still started and ran. Clearwater's making aftermarket heads. Edelbrock's making a high-performance aluminum head. If you love working on Jeeps as much as I do, time and money are not a factor. All right, that's it.